Now next problem appears to be a very long and tricky problem, but instead it is a very easy problem provided you go step by step. We are given with a function from -1 to 1 to r such that f dash 0 is equal to n into f of 1 by n, f of 0 is equal to 0, and we want to find the limit L, which is limit n tending to infinity 2 upon pi into n plus 1 cos inverse 1 by n minus n. Now these long datas of function f getting defined, the relation between f of 1 by n and f dash 0, and this defining of f of 0, they've all been given just to confuse you. They're not given exactly to confuse you, but these are the datas which are useful in the problem, but you should not get scared looking at these datas. Now function f has not been defined in any part of the problem, so we try to find out a function f such that f of 1 by n can be expressed as a function of f dash 0. We can get f of 0 equals 0, and we can define the function so as to find the limit of this expression. Now what we do is, we take this n common. We get limit L is equal to limit h tending to infinity n into 2 by pi into n plus 1 upon n cos inverse 1 upon n minus 1. We did this so as to generate a n outside this expression. Now the next step which we require to take is to generate a function of the form f of 1 by n. Now we try to convert this expression in the form of a function f of 1 by n. So what we do is, we rewrite the whole thing as limit n tending to infinity into n 2 upon pi 1 plus 1 upon n cos inverse 1 upon n minus 1. Now very obviously we can see this, that this is written in the form of n into a function of 1 by n. So we have got a function of the form f of 1 by n. So our next step is to find out f of x. So replacing 1 by n by x, we get f of x is equal to 2 upon pi into 1 plus x cos inverse x minus 1. Now we need to find out whether f of 0 is equal to 0 or not. We have just found out the function f such that f of 1 by n into n can be expressed as f dash 0. Now we also need to check whether f of 0 is coming out 0 or not. If not, we need to find another function f of n, or rather f of x, such that there is a relation f of 1 by n into n is equal to f dash 0, and f of 0 is also equal to 0. We try to find out f of 0. This is equal to 2 upon pi into cos inverse 0 minus 1, which is equal to 2 upon pi into pi by 2 minus 1, which is equal to 1 minus 1, which is equal to 0. So we have got f of 0 is equal to 0, and the other relation is also getting satisfied. So we can very confidently say that this is our function f of x. Now in order to find out this, we just need to find out f dash 0. For this we first find out f dash x, which is equal to 2 upon pi into cos inverse x plus 1 plus x into minus 1 upon under root of 1 minus x square. So now the value of f dash 0 will be equal to 2 upon pi into cos inverse of 0, which is equal to pi by 2. This is 1, this is 1, so this is pi by 2 minus 1. So we get 1 minus 2 upon pi. So we can very clearly see that such a long question and such a tricky type of question has got such a simple answer by using very simple approach. We didn't use any special formulas, we didn't use any special approaches like sandwich theorem, 1 power infinity, or nothing like that. We just used the basic approach in order to get the final answer as 1 minus 2 upon pi.